In this video, I will be going over lesson 20, which is about percents. Alright, so the main part with percents that you want to remember is this equation right here. This part over whole equals percent over 100. So say you had a problem that asked you for 50%. Since 50 is our percent, we would put this 50 over our 100. And then the part in the whole, you have to read the description to see, well, is that talking about all of whatever I have, or is it only talking about a portion of it? So let's look at our first question and figure this out. It says that a shipment of 700 pieces of glassware contains about 28 broken items. Part A is asking us how can we determine a proportion, and B wants to know what percent of the items are broken. Okay, so remember that the equation that we always want to use is going to be part over whole equals our percent over 100. Okay, so this shipment had 700 pieces and 28 of them were broken. So how many total pieces did our shipment have? 700. So 700 is our whole. And out of those 700, 28 are broken. So 28 is a piece or a part of the whole shipment. So 28 is going to go on top. I don't know what my percent is, right? That's the one piece of information I'm not given in this initial sentence up here. I'm given my whole and I'm given my parts, but I don't have a percent. So since I don't know what my percent is, I'm going to put a variable there. Okay, so the proportion that we want to use is going to look like this. Okay, so a proportion is two fractions that are set equal to each other. So if I'm looking through my answer choices here, I want to find what percent 28 is of 700 using this proportion here. Okay. And then B is asking, well, what percent of those items are broken? And to solve this one, there's a few different ways we can do it. I'm going to show you this one because it works every single time, regardless of which numbers you're using. Okay, so I'm going to do cross multiplication, which is where I multiply diagonally. So I'm going to do 28 times 100. Once I do one side, I'm going to put an equal sign. Then I'm going to multiply diagonally the other direction. So 700 and x. So 700 times x. Okay. From here, I am going to solve my equation. So if I were to do 28 times 100, remember you could type that into a calculator if you would like, I get 2,800, and that's equal to 700 and x. Now, if you remember from, I'm not sure if you know this before from past learnings or not, but anytime we're solving for a variable, we're going to use inverse operations. Okay, so if I look here, this 700 and x are being multiplied. So the opposite of multiplication is going to be division. And anything I do to one side of my equal sign, I need to also do to the other. So I'm going to divide both sides by 700. That means this will cancel. 2800 divided by 700 is going to give me 4, and that is x. And if I look up here, x represents my percent, so that means that B is going to be 4%. Okay, so with these problems, you want to first set up your proportion, do your cross multiplication, so you're multiplying diagonally. Okay, then you're going to want to multiply out whatever side you can. Here it was this 28 over 100. And then your next step is going to be dividing by whatever number is next to your variable. Okay? And we'll do this a few more times so you'll see it multiple times. Our next question says that a $200 telescope is marked on sale for 30% off. How can you find the percent of the price reduction in dollars for the telescope? So this question is asking me, if it's 30% off, how much money am I going to be saving? So an easy way to do this one is to think about what our appropriate proportion is going to be. I know that the total price of the telescope is $200. So the whole price that I would pay for a telescope if it wasn't on sale is going to be $200. I'm going to have some percent over 100. Here is my 30%, so 30 is going to go up top, and I don't know what X is. X is actually going to tell me how much money I'd be saving. Okay, so knowing that I'm going to be using this proportion, I can cross off this one here because it has a 200 on the bottom. That's wrong, it should have 100. And I can also cross off this one here. Okay, the next step is going to be solving for our variable. So I guess I'm going to write this on the other side over here. So start multiplying diagonally, 100 times x. So 100 times x. Do my equal sign, and then I'm going to do the other direction. 30 times 200. Okay. Then I'm going to do my multiplication. So 100x is going to stay the same. 30 times 200, again, always type this into a calculator if you would like, just to be sure. This is going to give me 6,000. Then I'm dividing by whatever number is next to my variable. So here it's that 100. So I'm going to divide both sides by 100. These zeros are going to cancel, and I'm going to be left with 60. Okay, so that means that $60 is what I would save. That's how much money my telescope would be discounted. So my last step is going to be looking at the second sentence. Here it says solving for P, the price reduction is 170. And on A it says solving for P, the price reduction is 60. So this is the choice I want to pick. So make sure that my proportion is correct and that I would be saving $60. Alright, our next one. So one thing with these kind of problems is a lot of the answer choices usually look a little bit intimidating, but remember, start with what we know, our part over whole equals percent over 100, and go from there. See which ones I can cross off right away. This question says the results of a lab experiment showed positive results for 15 test subjects, which is 20% of T, the total number of test subjects. So I don't know what T is, and it says that T is my total number of test subjects. Okay, so if T is my total number, that's the whole. That is how many total people were tested. And I don't know that. So T is going to be on bottom for my whole. And I do know a percent, right? I know 20%, and your percent always goes over 100. And that means that 15 is going to be my part. So looking through these answer choices, this proportion here is not correct. This one is good, and this bottom one is good. Okay. I'm just making sure. Oh wait, this bottom one is actually not correct. I looked at it too quickly. Notice how T needs to be on the bottom, and here it is on the top, so we don't want to pick that one. Alright, so what we're going to do now is we are going to look at our two answer choices left, and we're going to see which one has the correct number for the total number of test subjects. Okay? So one of them says 30 and one says 75. Let's do our cross multiplication. So I'm going to do 15 times 100. Put my equal sign. Go the other direction. T times 20. 15 times 100 is going to be 1,500. I have 20t. Divide both sides by the number next to my variable, which is going to be 20. So I'm going to do 1,500 divided by 20. So 1,500 divided by 20 is going to give us 75. So that means for here, C would be correct. Remember, make sure that my proportion is correct, and I have 75. Again, don't be afraid to type in those multiplication and division steps into a calculator to double check your work. Alrighty. So the next topic we are going to be going over that deals with percents is percent change. Okay, this equation looks a little bit different. What it is the final amount subtracted by the original amount, and we're going to divide it by the original. Okay, and this will work mostly with money, right? So say I am buying a shirt and it's on sale. The sale price is the final amount because that's how much I'm paying, but there is a price before it goes on sale, right? The original price. So I would be taking my final amount, subtracting it from how much it was originally, and then dividing it by the original. And that is going to give us our percent increase or decrease. If you have a positive number, it is an increase. And if you have a negative number, it is going to be a decrease. Okay, so remember this equation here. I would recommend writing down these equations somewhere because we're going to learn a new one for the last workbook as well. So having these written down somewhere where you can look at them would help, because then once you figure out what each of these numbers are, you're just replacing them and you can pop this into a calculator. Okay, so let's look at our first question. After Linnea trades in her car, her annual insurance premium decreases from 500 to 300. Which fraction represents the percent decrease in Linnea's car insurance? Okay, so it used to be 500, so that's how much she was paying originally, 500, okay, and now it is down to 300. So her original amount, oops, I'm actually going to go back, look at this equation. Final amount first. So she is paying 300, okay, and we are subtracting that from 500, what she paid originally, and we're going to divide this by 500. Our next step is going to be typing this into a calculator to figure out what our reduced fraction is. So I'm going to bring over Desmo, so I'm going to shrink it a bit. Hit my fraction button, 300 minus 500 all over 500. And it's interesting because, so when I reduce this, I get a negative 2 over 5, and that's not wrong. So 2 over 5 is technically correct. However, none of the fractions are reduced to the simplest form. So if I take the top and bottom here and multiply both by 2, right, I would get 4 over 10, which is this one here. So that is correct. 4 over 10 is correct. And then the final step in figuring out what the actual percent is remember, in order to have a percent, it needs to be over 100. Okay, so if I have a 10 in the bottom here, I could do 10 times 10 to get to 100. So let's do the same thing up top. 4 times 10, it's going to give me 40. So that means that the percent decrease that she had on her car insurance is 40%. Our next question says that a small town newspaper examines its daily circulation. Last week it sold 200 newspapers daily. This week it sold 186 newspapers daily. What percent decrease in the newspaper circulation since last week? Okay, so part A is asking us for the percentage right away. And so it sold 200 newspapers daily, and this week it only sold 186. So for this week, 186. Last week it was 200. And remember, we're always going to divide it by the second amount here. I'm going to pull this into my calculator. Hit my fraction button, so 186 minus 200 over 200. And I get this decimal. Okay, this decimal is fine. What you could do when you're using your calculator to solve these is if I take my decimal, so type in 0.07, and I multiply it by 100, this is going to give me what the percent is. Okay, so once you type in your fraction, multiply it by 100, and that will give you your percent. When I multiply it by 100, I get 7, which means that it was a 7% decrease in sales. B says if circulation decreases by the same percent next week, what will the daily circulation be? So for B, it's going to be a little bit different. When we ended our week 1, we were at 186, and it's decreasing by 7%, which means I need to multiply this by 7%. However, you cannot multiply by percentages. You must change them into a decimal. Okay, so 7% as a decimal is 0.07. If you don't know, you could always take your percent and divide it by 100. This will give you your decimal. Okay, so if I did 7 divided by 100, I would get 0.07. So let's take those two numbers, multiply them together. So 186 times 0.07. This gives me 13.2. So that is how many fewer newspapers I will sell. So I need to take that 186 and subtract it from how many less I will be selling, which is 13. So I will have 173 newspapers sold the following week. So that question was a little bit different. All right, next question says that a family moves out of a home that is 1,500 square feet and into a home that is 2,400 square feet. Part A wants to know which expression represents the percent change. Okay, so remember, the original square foot of their home is 15. So 15 is their original, and their new or their final square foot of their new home is 2,400. So I would take that 2,400, because this is my final, and subtract it from my original. Remember, you're always dividing by the second number in the back. And when I look at my equations, this one here is correct. You have to look very carefully. This one almost is correct, but it has the wrong number on the bottom, which makes it wrong. And these two equations are flip-flop. So right off the bat, I know those don't look right. And then part B is just asking us, well, what is the actual percent increase of our home? So if I type this in, my 2,400 minus 1,500, all over 1,500, I get 0.6. Remember, I can take that decimal and multiply it by 100 to get my percent, which is 60. So it is a 60% increase in size. All right, next question. Our next question says that the temperature in Quepos increased from 80 degrees on Wednesday to 90 degrees on Thursday. This is a percent increase of blank. All right, so we're asked to figure out what the percent increase is. So again, it went from 80 to 90. So 90 is our final temperature. 80 is the original. So that means we're also going to be dividing by 80. Remember that once we type this into our calculator, all we need to do is multiply it by 100 to get that final percent. So I'm going to bring back my calculator and hit my fraction button. Do 90 minus 80 all over 80. So 0.125, I'm going to multiply it by 100. And that is going to give me 12.5. So it was an increase of 12.5%. And for blank 2, we want to know what the final temperature is. So if the temperature increases by the same percent on Friday, it will be what? Okay, so our temperature on temperature on Thursday is 90. It's increasing by 12.5%. So we need to take this 90 and multiply it by 12.5%. But remember, I need to change this back into a decimal. You cannot multiply by percents. It'll give you a huge number and it won't really make too much sense. So let's change this to a decimal. Remember, you can always take your percent and divide it by 100. That will give you the same number. And once we have this number, we need to take it and add it to 90, because this number right here is going to tell us how much our temperature is going to increase. Okay, so this is going to represent our temperature increase. So we need to add that to 90 to figure out how hot it's going to be on Friday. All right, so let's clear this up. I have 90 times 0.125. which means it's going to increase by 11.25 degrees. So I'm going to take that 90 and add it to 11.25, which gives me 102.25. So that is going to be how hot it will be on Friday. All right, our very last workbook for lesson 20 is talking about percent error. Okay, and the percent error formulas can look a little bit weird, but it's actually not too different from our percent increase and decrease. It just has this absolute value sign on top, which means that we're always going to have a positive percent error. Okay, so your percent error will always be positive, it won't be negative. But if I look here, it's the measured value minus actual value over actual, and I'm multiplying it by 100. That's very similar to what we have been doing. Okay, so when you're asking for percent error, remember it's always going to be positive. So if you ever see a negative answer, it is not negative, but this is only for percent error. Okay. Our first question says that the listed weight of a steel beam is 88 pounds. So that's what it's supposed to be, 88. And an engineer weighs the beam in his shop and records the weight of 86.5 pounds. So we want to know what is the absolute error listed for the beam of the weight, or weight of the beam. Okay, well, the absolute error for how the discrepancy in the weight, it's supposed to be 88 pounds, but this engineer only got 86.5 pounds. So I just need to figure out how many pounds are missing from what he got versus what is advertised. And to do that, I just need to do some subtraction. Okay, so 88 minus 86.5, again, you can type this into a calculator if you would like. When you do that, you should get 1.5 pounds. So for blank 1, it is a 1.5 discrepancy. He's missing 1.5 pounds of his beam. Okay, blank 2 wants to know what the percent error is. So this is where we take this 88 minus 86.5, divide it by 86.5, and multiply it by 100. I'm just going to look here. Yes. Oh, whoops, this is actually backwards. Sorry. So I'll go over that in a second, why this is backwards, in just 1 second. So notice how it's my measured error, or measured value. So when he actually weighed his beam, it weighed 86.5 pounds, and that's what the measured value is. The actual value, hold on, I think I'm confusing myself now. I'm so sorry. I was right the first time. So the measured value should be 88, and the actual value that he actually weighed it as is 86.5. I apologize. I was reading too far into it. And then don't forget to multiply it by that 100. So 88 minus 86.5 over 86.5. I'm only going to type in a few of these decimals. So 1, 3, 4. Let's do that and multiply it by 100. I get 1.734. So that means there is a percent error of 1.7%. So that company had a 1.7% error in the weight of its beam. All right, our last question. So the accepted density of copper is 8.96 grams per centimeter cube. A lab team measures the density of a copper sample in a lab and calculated the density of 8.4 grams per centimeters cube. Which expression calculates the percent error for the calculated density of copper? So we are asked essentially which one tells us the correct setup, right? With our absolute value signs. Right off the bat, I'm going to tell you right now, I can tell this one is wrong because it is not in the right format. This one is also wrong because it's not in the right format. If I go back, our format should be this. We should have subtraction from two numbers in the top, and we're multiplying by 100. Both of those answers had the wrong setup. So now I'm left with only 2 for A. And it's up to me to determine, well, what is the measured weight and what is the actual weight? So the measured weight is supposed to be 8.96. However, the actual density that this lab team received is 8.4. And we would be multiplying it by 100 once we do all of our dividing. So if I look, It should be this one up here, simply because those two numbers are the same and these two are not. But I set up mine differently. A team measured the density. Maybe that was my mistake, because it's the measured value. So since this team measured the density at 8.4, that is why I accidentally swapped these two numbers around. That makes more sense. So I read that too quickly and I missed that key detail to tell me that the measured value was 8.4 and the actual value of copper should be 8.96. So that was where I made my mistake, and that's okay because I was able to find my mistake using the different answers because I knew this one did not make sense. Alright, so next thing we're going to do is we're going to type this in. And I can insert those absolute value signs by hitting this button here, doing 8.4 minus 8.96. I'm going to divide that by 8.96. And I'm going to take this decimal here and I'm going to multiply it by 100, which gives me 6.25. So that means the actual percent error for this problem is going to be 6.25. Okay. That is the last question I have for lesson 20. The questions on lesson 20 are definitely a bit difficult and they move quickly within the 3 workbooks. So take it slowly, read the questions carefully, and you should be good. If you have questions, please let me know.